Today in our class we will discuss about the constructive cost model, CoCoMo. Okay, let's see how CoCoMo comes. It comes from the word cost, okay, CO from the cost, and now the CO from the constructive and MO from the model, so it comes the CoCoMo, okay, CoCoMo model. Actually, this is in continuation of the last class. That is, in the last class we have discussed about software cost estimation, and this is one of the very commonly used software estimation model. So this model is developed in 1981 by Barry Boehm to give the estimation of the number of man-month it will take to develop a software product. Okay, so man-month, that means we say that person month. Okay, that is nothing. It is a effort, right? This is effort. Person month is nothing. This is a effort. Okay, so CoCoMo predicts the effort and schedule of the project based on the size of the software. So anyway, whenever we discuss in the previous class, we said that in order to find out or in order to estimate the cost, it is based on the effort and the schedule, which is again based on the size of the software. Okay, how long it will take time and how much effort will be required. It is based on the size of the project or complexity of the software, right? So it is regression model based on the line of code, that is a procedural cost estimate model for software projects, and often used as a process of reliably predicting the various parameters associated with making the project. What are they? That is size, effort, cost, time, and quality. Now let's see, when we develop this whenever we are estimating this project cost, okay, or project effort or the project schedule, know that most important factors contributing to the project's duration and the cost, especially, okay, where we know that we have to estimate it in order to get the cost. The effort has to be calculated, schedule has to be estimated. So based on our effort and schedule, the cost of the projects, we can estimate it, isn't it? So as much as you delayed the schedule, then the effort of tracking the project is more, right? So the project's duration and the cost is the most important factors contributing to a project's duration. The cost is development mode, or also maybe defined as a class. Okay, there are mainly 3 modes or classes of the software project. So let's see. Number 1, this is number 1, organic mode. In this mode, relatively simple, small software projects with a small team are handled. The project is developed in a familiar, stable environment, and the product is similar to the previously developed product. Such teams should have a good application experience required and little innovation. So we this is the first one, which is normally this mode we use. This is normally used for the simple or small project. Okay, so definitely we need the small team size also, with the less experience or the little innovation. the team members. Okay, and now come to the second one, that is number 2, semi-detached project. In this class, intermediate projects, which is team with a mixed experience level, are handled. Such project may have a mix of rigid and less than the rigid requirements. The project's characteristics are intermediate between the organic and embedded. So we are having now 3, so it lies in between the organic and embedded. So this is intermediate size, that means intermediate size project. Okay, so since this is intermediate, means it is bigger than the organic mode, we need more experienced level team members. Then let's come to the third one, that is embedded projects. In this class, projects with the tight hardware, software and operational constraints are handled. The project is characterized by the tight, flexible constraints and interface requirements. An embedded mode project will require a great deal of innovation. Okay, a great deal of innovation. Okay, we can make it out clear. We can say with these comparisons, let's try to distinguish these 3 modes: organic, semi and embedded. So normally you see that the project size is different. You see one organic, this is 2 to 50,000 line of code. Okay, typically semi-detached 50 to 300,000 line of code, whereas the embedded is more than 300,000 line of code. Okay, so see, in terms, even in the size also, these 3 are varied. This is the smallest, that organic is the smallest, and the intermediate, the semi-detached is the intermediate, whereas the embedded one is the very large and the complex software. Okay, as we have already mentioned that this is for small project, and here experience, of course, experienced people are always required in order to develop the software. So experienced developer in a familiar environment. This is in the familiar environment, like supposing you are making a payroll system. Okay, so if you are making a payroll system, it may be same more or less like inventory project or maybe a banking system. These are all small the mod project. Okay, small size project, I mean that small size project which we can complete within the 50,000 line of code, and those people working here should have an experience on the similar environment. Okay, the same like here, nature of the the semi-detached is medium size, of course, and here we need the mixed experienced people. All right, and some of the example here is that utility system like compiler, the database, etc. Whereas that embedded one, which is a very complex and large project, which is normally work for the real-time system. Okay, so here in this means class, okay, in this mode, then we have the complex interface in general, and very little previous experience you can get it, because say mostly these are AI based, or that custom, okay, AR based and the custom software. So we will have a definitely a less experience. So one environment to another environment, one system to another system, okay, maybe very much different. Here this is what we say that large project, real time, and it's in terms of the size also, it normally takes more than 3,000 lines of code. Okay, these are the difference between the organic, semi-detached and embedded mode of development. Coming to the next point, that is a CoCoMo model. Okay, like the modes, different development modes, here also we are having 3 different models that reflects the complexity here. Okay, complexity. Remember the complexity here we have discussed about the mode, that is size, and the nature is different, right? So here let's see how this what are these different models. The first one, the basic model. The second one is intermediate, and third one is the detail, or also known as the complete model. Okay, so we'll see about all this briefly. The basic model. The basic CoCoMo model estimates the software development effort using only lines of code. What we are calculating? We are calculating the effort, isn't it? Using what? Using only lines of code. Okay, so we are having a various equation once again, like we have discussed in the previous class. That is effort. E is effort. Once again, D for duration, that is the time taken for developing the software. Persons required for developing the software, P. Okay, so how we are calculating? As we know that basic model, okay, calculate the effort. What is the first equation? That is, in order to calculate the effort, that is AB into 1000 line of code. Okay, AB into 1000 line of code, and BB person month. Person month is the effort, we know that, right? Then this AB, okay, here you see that this all coefficients AB and BB and CB, DB, these are all like it is having a constant value that we will see in the next slide. Okay, and once you got the once we estimate the effort, then it is easy to get the duration, that is the time taken to develop the project. Okay, using this equation, that is CB into B into DB, months. Okay, it will come in terms of the month. And finally, we already have the effort and duration. That means percent, to definitely it is we can easily calculate that percent, how many persons will be required, then effort divided by the duration. Okay, so now let's see here what are those values. Okay, that those coefficient values according to the different modes. It is different, organic and semi-detached and embedded. Each A, B, BV, CB, DV values are varied. Okay, let's we can by heart this very few numbers, few variables. Otherwise, let's see it how we can use this with some simple example here. First of all, let's take this example. Okay, consider a software project using what we are going to use it, semi-detached mode. Consider a software project using semi-detached mode with the how much is this? 30,000 lines of code. Okay, we are having 30,000 lines of code. We will obtain the estimation for this project as follows. So what is the formula? First of all, the E, you know that this formula we can use it because this semi-detached, we know that it is lies in between the, means it used a formula for that the organic as well as the embedded one. Okay, so we are using here the equation that is given in the basic model. Okay, and this is semi-detached one, right? I'm going to use the semi-detached one because see here basic, but we are having organic, semi and embedded, whichever depend on the size. So in this case what we are saying is that this is 30,000 lines. So what is 30,000 lines? Okay, so that means you know that this comes around that 30,000 30,000 lines of code. It comes under the semi-detached, okay, in between the organic and embedded. And come here, the formula is that EAB kilo lines of code, okay, BB. So we already got the constant value here. These coefficient values are given in the table, right? That is, since we are using the semi-detached, what is the value here? The semi-detached, in the semi-detached, the AB value is 3.0, isn't it? Right? So what about the BB? That is 1.12. okay, so only thing is that we are going to multiply this, okay, multiply this to 3.0 into lines of code to the power 1.12, isn't it? So you see that here you are getting only 30, not the 30,000s, because we are calculating in terms of the K, thousand, okay. So 30,000, this is the LOC, right? Your LOC, but I am going to calculate as a KLOC, so that's why that is we are getting only 30 here, okay, remember it. And this coefficient value is 1.12, okay. Using your calculator you can just find out the value, and we are getting here 135, means the 135% month is required, okay. Means our effort required in order to have this project, that is 135% month. The same thing here, we can also replace the value to calculate the duration, that how long it will take time. We already got the value here, 2.5, okay. Here you see, remember once again, CB into B to the power dB. Let's find out the values of the CB and dB. CB, how much is that? Okay, 2.5. all right, 2.5 is the our value, remember this, okay. And dB is 0.35, right? So just replace the value, because we already calculate the effort. And how much is effort? 135, okay. So definitely after multiplying all this, then we are getting 14 months, okay. That means we are using say 135% month, okay, percent month, and then it will take, if you are using this much effort, okay, then in order to complete this project, then we will need the 14 months, clear, right? This is our effort, this is our month, and now we already have the effort and month. So finally, how many persons will work? How many persons? Okay, the human resource required is the person, okay. That is effort divided by the duration. So we need 10% approximately to work for the project. All right, this is how we can estimate the project, okay. This is the purpose of having this model, okay. So now comes to some basic advantages and disadvantages of this model. One of the advantages here is that this is good for quick, early, rough, okay, means rough order of estimates. You know, here this is not the big size, isn't it? This is the basic. Normally we can use yes, of course, we can use it for that different development mode, that is organic, semi-detached, or embedded. But here, if you are using this basic model, then it is fast, okay. So if it is early, rough, and then about the disadvantage. One of the disadvantages is that accuracy is limited here. Okay, remember it, and you can remember that it cannot be used for the modern tools. It doesn't consider the different parameters because it consider only the line of codes, isn't it? Basic CoCoMo model works on line of codes. It doesn't consider the different other parameters. There are so many other parameters in project development. So this is the main advantages and disadvantages of having this model. Come to the second model, that is intermediate model. So this estimation model makes use of the effort as a function of program size and a set of cost driver attributes that includes subjective assessment of the product and hardware, personnel, and project attributes to compute the cost of the software. Okay, so what are they? Those software drivers are, okay, cost driver attributes that include the subjective assessment that required is in terms of the product attribute. Okay, when you see the product attributes, then we can consider that required software reliability, that is the accuracy, is one of the product attribute, isn't it? Right? No, accuracy, how far the software is reliable, that is accuracy of the product, how accurate is the product. Okay, size of the application database, okay, the database that we use it in that software, and complexity of the product, these are the product attributes. So likewise, we also have the hardware attributes. Is normally it can include any of the hardware, but mostly what hardware we are using here, we are using computer, isn't it? So in some you may find like computer attributes also, but here I'm using the hardware attributes. Okay, it may consider the run time or execution time or performance constants, whatever the constants of this execution time. Okay, and then maybe any kind of the constant, okay, memory constant, okay, speed of the system will be again depend on the memory. So memory, this is memory constant, right? So a virtual machine, right? And then virtual machine, your volatility, right? Computer turnaround time, all these things are the attributes of the hardware, especially the constant are focused here. Okay, then next to this, the personal attributes, that is analyst capability, programmer's capability, application experience, okay, virtual machine experience, programming language experience. These are all that the personal, the attributes of the personal that we are going to engage to develop the software. Okay, and then finally the project attributes. It's about the modern programming practices, use of the software tools. Okay, these days we are having a lots of that inbuilt tools, templates, many are there, so reusability is there. So those are some of the practices that is comes under the project attributes that you can or we can use it. All right, so these are the factors, these are the cost drive attributes that we use to estimate using this intermediate model. Now like the basic model, here also we are having that effort, how to calculate the effort. Okay, AI into 1000th line of code to the power BI into EAF. This is the effort adjustment factor. Okay, there will be no effort adjustment factor. We are going to take the average of that to adjust that effort. Okay, so that will come like after getting all the all this this cost drive right? Here I say that here many cost drivers will be there, cost driver attributes. We used to give some rating there. Okay, so from that we take the average and then calculate the effort adjustment factor. So using this equation you can calculate the effort. Okay, so the same thing, the coefficient values are given here. AI and BI we are using, we are having, so this, if it is organic, okay, then semi-detached and embedded, all the values are given, constant values given. Only thing is that we have to calculate based on that line of code once again, okay, into the what, effort adjustment factor. Okay, so in the basic CoCoMo model we use only line of code, and here we are using that another factor, that is EAF. Remember that. Okay, we will not consider take any example here. This, like before, you can just calculate it by by substituting that the values. Merits and regarding the merits and the limitation, that is advantages and disadvantages. So first of all, it can be applied to almost entire software for easy and rough cost estimation. Okay, it can be applied at the software product component level. It's good, no? It is, we can apply it at the software component level. And many more limitations still there. That is a major shortcoming of both the basic and intermediate CoCoMo model is that they consider a software product as a single homogeneous entity. Alright, so now these days large software systems are made up with the several smaller subsystems or the modules with the different characteristics. So like this, we have some disadvantages. We can go for the third model, whether, let's see whether it gives better better effort estimation or not. Now coming to the detail, or also known as, we say that complete, isn't it, complete model. So the detailed model uses the same equation for estimation as the intermediate model. Alright, so I will not repeat it here because see, we have the E, we have the duration and no person, but the detailed model can estimate. Now this tree we already got it in the other model also. The complete CoCoMo model considers different subsystems of the software. For example, say a website has a different modules or the subsystem. Unlike the previous two models, in the previous two models it is homogeneous, isn't it? We were unable to estimate the the subsystem. We do not consider the subsystem of that entire software, right? So now in this case, we can use, or we can consider different subsystem of the software also, being there may be so many modules these days in the software, right? So it is an example here. We can consider these factors, that is a graphical user interface, that is front end, we call that front end every software, right? Then database, that is stored data. This is also, I think that this is also known as the back end, isn't it? This is back end, whereas whatever the interface we are designed, that is our front end. So if this software is there, then software that the back end, the database is we used to access the database with the help of this interface, isn't it? And then communication part, these three factors are considered in this case. Okay, this, and you see communication part can be considered as embedded software, The database part could be semi-detached software, and GUI part as an organic software. Alright, so all the modes can be now we can consider differently as communication part embedded, whereas database part as a semi-detached, and GUI part as an organic. That is the most simplest form of our development mode, isn't it? So the cost for these three components can be estimated separately. You know that these are all separate modules, so we can calculate the cost for these three modules separately and then sum up to give the overall cost of the system. So like this we can get the detailed and more accurate estimation using this detailed CoCoMo model. Now very few say models here for estimation, how we approach. Okay, about the approach, that is it top-down approach, uses the size but adjust using some factor. The basic procedure is obtain initial estimate using size. Okay, obtain initial estimate. How we obtain the initial estimate, we know it, isn't it? For example, E using the size line of code, we used to get the initial estimation, isn't it? So determine a set of 15 multiplying factors from the different project attributes. We have already learned about the 4 different project attributes. Okay, there will be minimum set of 15 multiplying factors will be there. Adjust the factor and adjust the effect estimate by scaling it with the final multiplying factor. Okay, so in this estimation, you know that we did it a into the size power b. Okay, this some standard value for a and b is given for different project type, right? That we have seen, no, the a into that say for example calculating the E effort, then the constant value into line of code to the power BB is given, isn't it? And there are 15 cost driver attributes: line, reliability, complexity, application experience and capability, and so on and so forth, many more. 15 will be there. Okay, we will see it. Then each factor is rated. Each factor is rated. Okay, and for the rating, a multiplication factor is given. We'll see with the example later. Final effort adjustment factor is the product of the factor for all the 15 attributes. We know that, isn't it? FEA is multiplied to the effort in the intermediate that CoCoMo model, right? So some of the cost driver, we say that there are 15. Okay, so some of the, I'm saying that some of the cost driver are like reliability, database size, product complexity, execution time, memory constraint, analysis capability, application experience, programmer capability, use of the software to see. Many have been given in that different 4 attributes, isn't it? That then we rate it here, that is from the low to very high, very low to very high. Okay, very low, low, normal, high, and very high. These are the normal rates we have given. So at least 15 cost drivers required. Okay, and then we have to take the this final effort adjustment has to be made. effort adjustment factor will be calculated from this 15 rated values. Clear? Now we can summarize, that is, effort distribution among the different phases is given as percent of the effort. For example, for the medium size product, it is product size, okay, medium product size. For the product design, you can give it 16%. For the detailed design, 24%. And for coding and unit testing, 38%. For integration and test, okay, integration test, and then other the system testing, maybe maintenance testing, okay, whatever the testing after the unit testing is the integration and the system testing, 22%. Right here, this is the effort distribution. You know that supposing how much we are having 100% effort is required, right, for the full functioning of the software. You see, then in order to give the function our software or the product or project within the budget, within the time, with the defined quality, within the predefined scope. Okay, so here we need our full 100% effort is how we can distribute it. This is an simply example. You see that design, up to design 16% only. The previous means starting from your analysis till the design part, then you are given the effort up to 16%, whereas the detailed design again 24%. But in the coding, how much is this together? Okay, 0, 3, 4, 40% together now, right? 40% given. And then here coding and unit testing. Definitely unit testing is done by the programmer only while they are coding, isn't it? I'm developing one unit, okay, I'm writing one unit, that unit has to be tested. That is why coding goes with the unit testing, the 38% effort required. Whereas the integration and testing, this is so many units are there, so we have 1, 2, 3 units, okay, so maybe there is many more units there, so every unit is tested by the programmer during the coding, then it has to be integrated, right? It has to be integrated. All the systems should be the units should be integrated, and that is called integration testing. Maybe you can there are different approaches maybe there, that is you can integrate the 1 and 2 first, and then the product of this 1 and 2 and integrate with the 3, or you can okay, let's suppose that everything is done, the integration is done, and the integration and test, that is overall system has to be tested after integrated properly, that is 22%, okay, right? So we are having the remaining, this is how much is this, 0, 6, 60%. So where we are giving more time, where we are giving more effort, okay, we can calculate it from by using these different CoCoMo models, and then here we are calculating all about the efforts, isn't it? Effort, mostly effort and schedule by using this. So what we are calculating is, we are calculating effort, all effort, we know the effort, and if we know the effort, then we calculate the schedule, how long it will take time, isn't it? If we know the effort and we know we can get the schedule, and then if we know the board, then we can find out the number of persons required to complete the project. So these are how we estimate, these are what we are finding using this model, that is the CoCoMo. Clear? And we even can distribute it the effort also. Alright, so that's all for today. Let's discuss in the next class.